Hi, this is Terry, and we're going to do cost behaviors in this section and then CVP analysis in the other one. So I'll say hello to you. And this is using the Garrison Transparency Masters. So we're going to jump right into number 2. Well, that jumped to 5, so let's go back up to number 2. The idea here is that we're looking at behaviors of different expenses that we have. So we want to divide them into 2 categories. The first one is variable costing, and variable costing is going to be any cost that changes in proportion to the activity. So for example, if you were going to make no bicycles, then you would have to spend no money on those bicycles to buy a chain. But if you were going to make 100 bicycles, then you would, at $8 per chain, then you would have to spend $800. So the idea here is that as production increases, so does that cost increase, and it's at a direct or constant relationship of $8 per unit. So, and that's kind of a key concept, that the per unit stays the same. It's $8 per bicycle chain, but if we make no bicycles, we don't need any chains. If we make 100 bicycles, then we need 800 chains at $8 a bicycle. So this creates a line that goes right through our origin and has that slope of $8. If we go down here, then why does it keep jumping here? Let's get back to it here. Examples of variable costing would be the variable cost of goods sold. So that's going to reflect your direct materials, your direct labor, and your variable overhead. In addition to that, you're going to also have variable selling and administrative costs. So you'll have variable selling and variable administrative. The counterpart to this then is a fixed cost, and a fixed cost remains constant over different levels of activity. So for example, if we have $50,000 is the rent on a building, and we don't make any parts, we don't make any this happens to be photo sessions, so if we don't have any photo sessions, we owe $50,000 for the rent of the building because we signed the contract. If we have 1,000 photo sessions, we still have the same amount of rent. It's still going to cost us $50,000. So as production increases, the total amount here stays the same. It's constant. If we look at that concept and apply it to a per unit basis, then this is the whole concept of why you have manufacturing, is that as the fixed cost is spread over more units, then each unit has to pick up less of the expense. So again, you need to catch that this is on a per unit basis, that flat line was in total, but when we convert it to per unit, then our costs will go down as we produce more. Types of fixed costs are going to be items like depreciation, taxes, fixed salaries of our key personnel, your advertising and research, public relations, all these items. They actually call them discretionary because after a certain point in time, you might sign a 3-year advertising contract, and after 3 years then you can change it. But depreciation and taxes and the salaries for your key personnel, those you're always going to have. Those are committed. Those aren't going to change. Moving on then, sometimes we have mixed costs, and a mixed cost is the concept of you have a variable and a fixed. So your fixed component would be right here, and your variable component would be the upper line. So here's our variable component, there's our fixed. This should make sense. Something like a commission for a salesperson. They get a base salary of $50,000 a year plus $500 for every photocopy machine that they sell. So when they get their check, they get the fixed amount, but then they also get the variable component depending upon sales. This one's using the concept of $2,500 plus 2 cents per photo developed is going to be the cost of developing those photos. There's a fixed and a variable component. And this intercept here is called alpha, which I believe is on the next slide is what we're going to look at as the equation of a line, or we can just do it right here since I have white space. It takes 2 points to determine a line. So we have the corresponding, whoops, that didn't line up, the corresponding x value and the corresponding y value, and then the corresponding x value and the corresponding y value. So you learned this in your mathematics that you had in school, that you probably learned it as y2 minus y1 equals m times x2 minus x1. That is the 2-point formula, and what we're going to use instead of m is use beta. And then if we divide both sides by x2 minus x1, x2 minus x1, then ultimately what you get is beta is the change in y over the change in x. So you learn that as rise over run. You learn that as rise over the run. And that slope becomes the variable cost per unit. So beta x would be, if x is the total number of units that you're going to sell, then beta x would be your total variable cost. With that 2-point formula, if I jiggle this, all that writing will go away, so let me make it go away. There we go. Then with that 2-point formula, we know that y equals alpha plus beta x. That's the equation of a line. So if we have solved for beta with the 2-point formula, that beta is solved, and if we substitute one of the x values like x1 and y1, we substitute in those values, now we can solve for alpha. The reason that we want to do this, you're going to see on the last slide, is that we want to take all of our expenses and convert them either to variable or fixed. And if they're variable or fixed, it's not a problem. The issue becomes is when are they a mixed cost, like shipping, those kind of issues. Well, one way that you can resolve that is to use the first method, is the scatter graph method. And the scatter graph method is that you just simply plot all those points. So you put in the $1,500 and you would say that that's 42,000, or 1,500 units, excuse me. And the 1,900 then, would be here, and that's going to be 46,000, etc. So you plot all of these different points directly onto a graph. And if we slide down a little bit, then you'll see that what it looks like when a scatter graph is completed. So now you've got all these points. If you plot that point and just use a ruler and try and get equal number of points above and below the line, then you're going to create your alpha. And if you use one of these points that you know the x value, so y equals alpha plus beta x, you know this x value, you know the y value, and since you know the alpha value, then the only value left to solve for